Hi, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video, we are going to see about Colpitts Oscillator. The Colpitts Oscillator is also an LC oscillator like Hartley oscillator. So the Colpitts oscillator consists of two capacitances and one inductor in the tank circuit. Let Z1 and Z2 are capacitors and Z3 is an inductor. The resistors R1 and R2 and RE provides the necessary DC bias to the transistor. And C is the bypass capacitor. CC1 and CC2 are coupling capacitors. The feedback network consists of two capacitors C1, C2 and one inductor L. And these three components determines the frequency of oscillation of the oscillator. The supply voltage plus VCC is switched on and the transient current is produced in the circuit, and consequently damped harmonic oscillations are set up in the circuit. The oscillatory current in the tank circuit produces AC voltage across C1 and C2. As terminal 3 is connected with earth or ground, it will be at zero potential. If terminal 1 is at positive potential with respect to 3, then at any instant terminal 2 will be at a negative potential with respect to 3. Thus, the phase difference between the terminals 1 and 2 is always 180 degree. And in the common emitter configuration mode, the transistor provides the phase difference of 180 degree between the input and output. Therefore, in total, we are having 180 plus 180 is 360 degree phase shift. Thus, at frequency determined for the tank circuit, the necessary condition for sustained oscillation is satisfied. If the feedback is adjusted so that the loop gain A beta is equal to 1, then the circuit acts as an oscillator. So, according to Barkhausen criterion, the oscillators must satisfy two conditions. One is the loop gain modulus A beta is equal to 1, and the second one is total phase shift around the circuit is 360 degree. So, now both the conditions are satisfied, therefore, this circuit will act as an oscillator. And the frequency of oscillation is F0 is equal to 1 by 2 pi root LC. So, where L is the inductance in the tank circuit and C is the combination of two capacitors C1 and C2. And totally we are having final C is equal to C1 C2 by C1 plus C2. So, now let us consider or let us take the impedance Z1 is equal to the impedance across capacitor C1, and which is represented as 1 by j omega C1, and 1 by j can be written as minus j. So, it is minus j by omega C1. And Z2 is the impedance across capacitor C2, which is equal to 1 by j omega C2, which is equal to minus j by omega C2. And Z3 is the potential across inductor L, and which is equal to j omega L. So, now substituting these values in the oscillator equation and equating it to 0, we get frequency of oscillation F0 is equal to omega naught by 2 pi, which is equal to 1 by 2 pi into omega naught is actually root of C1 plus C2 by C1 C2 into L. So, from this equation we can substitute C2 by C1 is equal to HFE.